So now we want to find for certain rational functions, which are polynomial divided by polynomial, points where there are vertical asymptotes. When is there a vertical asymptote? It's always there where it can only be there where the denominator approaches 0. But sometimes this is not necessarily a vertical asymptote. It will be a vertical asymptote if the denominator approaches 0 and the numerator does not. In case they both approach 0, then there will be some cancellation going on, and we have to do further computations. So let's discuss these two problems. Let's start with A. So, well, let's go here. So, in order, the first step we have to do, we have to find out points for which the denominator is 0. And since it's a quadratic, we will have to factor it. So x squared minus x minus 6 factors as x minus 3 times x plus 2. Aha. So the possible vertical asymptotes are x equals to 3 and x equals to minus 2. Now, what happens for the numerator? Well, for the numerator is also 0 if x equals to minus 2. So thus, we have to do a little cancelling. We have to compute the limit for x approaching minus 2 of x plus 2 divided by x squared minus x minus 6. And this, since we already factored this is limit for x plus 2 divided by x plus 2 times, what is it, x minus 3. And now, since we say x will never be equal to minus 2, not exactly, we can cancel this. So we get limit for x approaching minus 2 of the cancelled fraction, minus 3. And so this is, of course, 1. If x approaches minus 2, then, of course, x minus 3 approaches minus 5. So this is 1 over minus 1 over 5. Okay, so this is not a vertical asymptote. So now let us discuss the point x equals to 3. So we're looking at the limit for x. Let's do from the left and from the right of x plus 2. And let me already factor it here. It's x minus 3 times x plus 2. And now we can still cancel the x plus 2. So this is limit x going to 3 minus is 1 over x minus 3. And now we see if x approaches 3 from the left, this number is negative and closer to 0. So here this should be minus infinity. So this, and of course we can in the same way we can prove that the limit for x going to 3 plus, it's 1 over x minus 3 is plus infinity. So, and this is then vertical asymptote. Okay, let us do now the problem number B. In this case, the denominator is 0 for, well, when is the numerator 0? It's already factorized. X equals to 0 and x equals to minus 2. For both, the numerator is not equal to 0. So in this case, we have in the numerator a function not approaching 0, and in the denominator, the function approaching 0. So x equals to 0 as well as x equals to minus 2 are vertical asymptote.